So 5-3 notes are over finding the greatest common factor, and I already typed in the fill in the blank, so go ahead and pause it and then catch up on all that, and then I'm going to go work on the examples at the bottom. So the greatest common factor, which is abbreviated to GCF because we don't want to have to write all that out every single time, but the greatest common factor, or GCF, is the largest, aka the biggest, number that is a factor of two or more numbers. And there's two ways you can do it, and I'm going to show you both. One is you can use prime factorization, and then you multiply the prime factors, and prime factorization is what we did yesterday with factor trees. And then step 2 is to make a list. So after we do the 3 examples, you can figure out which process you like better. I like the making a list better. So the numbers 21 and 49, our goal is to find the biggest number that can be multiplied into both of these. Not the biggest number that both of them can multiply into, but the biggest number that multiplies into both of them. So it has to be a number smaller than each of these. So if I were to do the prime factorization for 21, which means make a factor tree, 2 digits that I can multiply to get 21 are 3 and 7. And those are both prime, so you would circle them. Okay, and then prime factorization for 49. Again, to get 49, you multiply 7 times 7, and 7s are both prime, so you would circle those. That's really sloppy. Okay, so you'd list it out. The prime factors for the prime factorization for 21 is 3 times 7. And then the prime factorization for 49 is 7 times 7. Hopefully I have enough space. Okay. So then after you list out the prime factorization, sometimes they have exponents like what we did yesterday, but in this example, neither of them have an exponent. And then you look at it. So 3 times 7 and 7 times 7. The only number that these two prime factorizations have in common is the 7s. And there's only one set of 7s they have in common. If there were another 7 on the top, if it were 3 times 7 squared, then it would be another set right here. But right now we're only focusing on these. So since there's two 7s, or there's a 7 in common in both 21 and 49, the greatest common factor is 7. And then I'm going to show you how to make a list. Okay. To do the list, you have to be good with multiplication, and you have to be good with the factors of 8. And, well, the factors of any number, but in this case, we're working with the factors of 8 and 52. So the factors of 8 and 52 start small. 1 will go into 8. 2, 3 doesn't, 4 does, and then 5 no, 6 no, 7 no, but then 8. And that's the biggest you can go. And then factors for 52, again, start small. So 1, 2, because it's even. 4 will go into it. 13, and then you don't need to go anymore because since the number 8, the factor stopped at 8, there's no point in going past 13 because none of those are going to be the option. So look at the common factors that they have. They have 1 as a common factor. They have 2, they have 4, and then it starts getting different, 8 and 13. Well, since they want the greatest, aka the largest common factor between 8 and 42 would be 4. So the answer for those is 4. Okay. 31, 51, and 85. So now we have to find the greatest common factor between 4 digits. Let's see. Factors of 31, 1. It's even, so 2 goes into it. And let's see, 17, which would just be cutting it in half. Oops. 51. 51 is not an even number, so 2 won't go into it. Let's see, 3 would. And then again, 17. And then we're on to 85. Oops. See if I can. Okay, so the factors of 85, 1, it's not even, so 2 will not, 3, no, 5 will. And then, let's see, the comma, so 17. So if you've already noticed the trend, 17 goes into all 3 of these numbers. And then 1 is also in common. The 2, 3, and 5 are not in common. 17s, and that's as big as you can go. So the greatest common factor between 34, 51, and 85 is 17. And that's it.